Welcome to the second part of our conversation with Guna. Guna, which has been a defining project in your career that has had an impact on you and also your geotechnical engineering career. Could you share some details about that project with us?
Yeah, I would say that, a lot of I mean, there are a number of projects, but the one that kind of, opened up was, I would say, the I-15 reconstruction project in preparation for the Winter Olympics in 2002 here in Salt Lake City.
Okay.
Was a big program for me. It was a project at the cost of $1.529 billion way back in 1996, one of the biggest or the biggest in the country at that time.
Yeah.
As you know that, one of the reasons I moved to the northwest part of the country is to sharpen my technical skills, because I, wanted to learn a little bit more about seismic design, liquefaction and mitigations. And, then I was here in Salt Lake where we are in a very soft Lake Bonneville deposits here in the valley.
Yes.
And so when this project came along, I took it on. I mean, I was asked to come and serve as the lead geotech for the owner trying to put the procurement documents. And so when we were writing, and I wrote the first performance specifications on this project for pavements, geotech, and environmental remediation and stuff.
Okay.
So it not only writing the performance specs opened up my eyes about all of the things. We were expecting, embankments about 25 feet high, 30 feet high, which was anticipated to generate 3 feet of settlement over its life, most of it primary and a lot of it secondary. And we were
Yes.
also in a seismic zone 4. So we had to make sure that in case of an event that all of the
Yeah.
these survived it, and we had looked at liquefaction potentials in a few areas. So we wrote this performance specs. So I learned a lot and was able to write the performance specs. And then when we got a design builder on board, they came up with some very innovative ideas. And one of the major applications here was the geoform. So if in order to minimize the load impacts on the subgrade soils, so that you don't have those large settlements, including large secondary settlements, which could be
Yeah.
detrimental to the pavement surface,
Yes.
came up with a suggestion and said we can minimize the loading using the geoform. So we have some huge embankments with geoform. So at that time, this project had the largest application of geoform. And
Great. Great.
also stabilize some of the subgrade soils using line cement columns. And then we accelerated these settlements in some places using, wick drains and surcharging. And then, we did a lot of different things on this project. So from a geotechnical engineering perspective, kind of, got me to work with a lot of experts from around the world. We had,
Yes.
so the settlements expected on the embankments, they came up with 2-staged MSC walls.
Okay.
The first stage, which would allow it to buckle and everything else, and then they would come in and put in a second phase to dress it up and things like that.
Yeah.
So those were all things, and I got to work with a lot of icons in the industry at that time who came to share their expertise. And then I also got to work on another project here called the Provo Canyon Project, which the highway going through Provo Canyon goes through a huge landslide, which is moving at a very slow rate and, has been moving for a while. So, that was another opportunity to look at, do we have, can mankind have the resources to hold that slide back, the mountainside is
Yeah.
coming down? Or
Yeah.
how do
Yeah.
you engineer a highway through a huge landslide? So, soil nails, all those kinds of things was another place to learn,
Yes.
done what, and so on. So those were the two. And then I've had the privilege of working around the country on major programs and projects. I worked on the $3.2 billion Tappan Zee, which is now called the Governor Mario Cuomo project across
Yeah.
in New York.
Yes.
We had to, it was a 3-mile crossing across the Hudson, lots of piles and everything else for the foundation.
Yes.
So there were a number of projects, but I would say as a geotechnical engineer, I-15 reconstruction in Salt Lake was one of those memorable ones and will always remain one.
Great, great, great. That's a huge project that you have been a part of, and with all the new technologies being used, I'm sure you had number of learnings as well.
Yeah.
Yeah.
And the department has, monitored this for a long period of time. So there are a number of papers written about all the findings and so on as well after that.
Great, great. Guna, which has been the most technically challenging project that you have worked on in your career, and why was it challenging?
Technically, in the sense, I mean, you're talking about technically, as I said, these two projects had their challenges in terms of
Yes,
how do we mitigate it.
yes,
And then we had another project here up north called the Legacy Parkway project that was also much closer to the Great Salt Lake, had a lot of settlement issues and liquefaction issues and stuff. So we had to come up with some plans, how do we go about mitigating it? And then we had two contractors, as part of a team. One was an earth moving contractor, the other one was a bridge building contractor. So the question was, the bridge builder didn't have the patience to let this earth mover to move the dirt, set it up there and let it sit for 6 months. He wanted to build his bridges.
yes,
Also came up with some ideas about, we had the issues of down drag on piles. If you drove the piles first and then came up and built the embankments, then, the settlements would cause a down drag. So we had some people come in and, do the analysis to see what can be done to make sure that, if you build the embankment after the bridge was built, that it's not going to drag the bridge down.
yes,
So we had a clear understanding of, what can be done, because, if
yeah,
you minimize the settlement at the neutral axis of your piles, because typically what they use here is the pipe pile
yes,
for bridge foundations. So if you took the piles deep enough so that you can minimize the settlement at the neutral axis of the piles, then you don't have to worry about, building the embankment after the bridge has been built. So
yes,
kind
yes,
of an interesting stuff. And then we had an interchange up north where liquefaction was a big issue. So the question was, what do we do? So we were looking at uh, doing a stability analysis of the embankment ramps that leading up to the bridge. So they were trying to figure out what to do because we had restrictions of right of way, and it had very marginal factors of safety. So one of the things that I suggested to them was we had a lot of scrap piles that were going
okay,
to be discarded anyway on the project. So I said, can we take some of those scrap piles and drive it along the right of way line down into the ground? So when you drive those scrap piles, because you're going to waste it anyway, if you drive it down
yeah,
there, what it did was it lowered the failure surface. And
yeah,
as it lowered the failure surface, it increased the factors of safety.
yes,
So that was, so see that they don't teach you in a
yeah,
school.
yes, yes,
All you know is how to do the analysis, and and if it's a factor of safety of less than 2, then you're worried about it. So
yeah,
that kind of an approach, how do you approach that pragmatically and come up with the solution? Because you can't afford to go buy more right away, but you still
yes,
get the embankment built and make sure that the embankment is stable. So
yeah,
projects here. And then there were some other projects, I was peripherally involved with in Oregon and other places, same thing about, landslides.
yeah,
If you're building in huge landslides, one of the projects where they built the, the columns and the bent, and then after some time when they came back, the whole column and the bent had shifted even before they could put the bridge back on. So what do you do? So Mother Nature has its own ways of doing it.
yes, yes, yeah,
So there's some projects, and then of course, if you go up north into Canada, you're dealing with frost heaves.
yeah,
So that's something else is challenging too, to make sure that your riding surface is not compromised because you're
yeah,
taking proper precautions.
yes, yes,
Every
yes,
project has
its own challenges. Yeah.
its own challenges.
Yeah.
And having worked around major programs around the country, I've had the good fortune of learning something from every one of them.
Great, great. Gunna, according to you, which are the areas in which there is an interface gap between the geotechnical engineers and structural engineers during the design phase of a project?
Typically, geotechnical engineers, you're asked to go do an investigation and generate a report.
Yes.
And what happens is, once you generate a report, I think, geotechnical engineers need to work hand in hand with the structural engineers. And that's the
Yes.
place that I always insist, in order to come up with an optimal solution, the overall optimal solution, you need to work together, because it's not like you just do your report, hand it over, and then it's done.
Yes.
An example, when I was in Texas, I did a field investigation, generated a report for a client who was from New York. And so there was a disconnect in the initial thing. So the structural engineer calls me and said, "Hey, I need a K value." I said, he said, "I need a K value." I said, "Nobody told me that you needed a K value, because we never knew about that during the initial investigation, and we never did any tests."
Yeah.
No, I need a K value because my computer program, I need to have an input parameter for K. So I told him, I said, "Well, it depends. Do you want a value for K, or you want the value for K?" It depends on which one you want. It's going to cost you money. So, so those are the kinds of things, you need
Yes.
to know upfront.
Yes.
What is the project? What is involved? Who's involved? What are they going to be using?
Yeah.
Softwares and stuff. What kind of input parameters would they need? You need to have, from the very beginning through at least a certain phase, you need to work with the structural engineers to have a good understanding, so that you can plan your investigation and be able to provide them with good information and good data.
Yes. Yes. Yes.
And invariably what happens is, even the loadings, you need to know what kind of loadings that you're going to, have to transfer to the
Yeah.
without going through major disasters. And there's a number of projects. You hear about the millennial
Yeah. Yeah.
in San Francisco,
Yes.
other places. Geotechnical engineers need to know a lot of information, so that they can provide the structural engineers with good information that everybody can be very comfortable with.
Yes, yes. That brings us to the end of our questions for today. Let's move on to the next interesting segment to explore Guna's imagination and take a few learnings from him. So, Guna, what have you imagined and sketched up for us today with a vision for the future without worrying about any of the constraints required to build it at this point?
One of the things that ASC has been working on, and as you probably know, we talk about the Future World Vision Project.
Yes, yes.
We showcased the floating city in Miami last in 2019, and in 2020 we showcased the megacity.
Yes.
And the World Bank, projects that 80% of the growth is going to be happening outside the United States. In a lot of places, we're going to have some megacities around the
Yeah.
world. So
Yes.
my sketch here shows kind of a combination of all. It's kind of a city in close to a waterfront, with a major bridge crossing across the waterfront, and then along with it comes mass transit, which is a subsurface condition on the right hand side.
Yeah.
So
Yeah.
this is a complex thing that a geotechnical engineer faces when you're building megacities.
Yes.
You have all the dynamics. You've got a subway system next to high-rise buildings. where there are a lot of utility lines going across, and you're in a close proximity to a waterfront, which means your groundwater is pretty high, and you're going to have to transfer heavy loads,
Yes.
these soft soil conditions, and maybe even some disturbed soil conditions. And maybe some of these structures are very sensitive to even very minor deflections and vibrations too. I've
Yeah.
been
Yeah.
involved in some projects here, especially medical facilities, where they have some very high sensitive, microscopes. They cannot tolerate any vibrations. So, so if you have a subway system running
Yeah.
to a medical facility that has
Yeah.
sensitive microscope
Yes.
research purposes, it cannot tolerate any vibration. So
Yeah.
geotechnical engineers need to come up with a way to dampen the vibration. At the same token, make sure that there are no issues with the settlements and other things. So geotechnical engineers are going to, be asked to understand the complexity of the entire setting, the surrounding. It's not, you can't put on a blinder and just look at your project and say,
Yes.
these are the requirements of my project, and all I need to do is that's all I need to do. Especially
Yes.
the city concept, you need to be worried about settlement of adjacent properties, impact to adjacent, utility lines, a lot of things. So a geotechnical engineer becomes an orchestrator,
Yes.
conductor in an orchestra, because you need to know what affects what and how it
Yeah.
affect when,
Yes.
so on. So
Yes.
that's the reason was for the sketch, is to say, it's not enough just to look at your project. You need to look around.
Yeah. Yeah. Definitely.
Geotechnical engineer, when I go to a project, I drive around. I just don't go to the project. I drive around to see what's out there, look for
Yes.
existing conditions,
Yes.
see what this could do and how it could impact. So that's the purpose of the sketch. You say,
Mm.
geotechnical engineers need to have a complete understanding of the environment,
Yeah.
not only of the present environment, but also of the future. Because
Yes.
the
Yes.
future will have a role to play as well.
Yeah.
So that was the reason for the
Yeah.
sketch.
That's a great imagination, Guna. Guna, as a takeaway for all our listeners of the show, could you share a rule of thumb that you have developed or followed during your career that might help our fellow engineers in the community to keep in mind while designing or analyzing structures?
As I was, I think I covered a lot of this thing. So
Yeah.
one thing is, I understand that, there's speed is a big deal today, and also, availability of information, and, being more cognizant about the cost. Um, I always tell people that you need to be honest with yourself and honest to the profession. If you feel that you can't just take what somebody tells you and say, this is all the money that I have, I want you to give me an investigation and a report, that's all I need. We have a moral and ethical responsibility to the profession and to the ultimate users of the facility and staff.
Yes. Yes.
First of all, when we're negotiating a contract, we need to be very careful. I can give you an example. My American dream was fulfilled some time back. Did a very small investigation for a residential property,
Okay.
and then years down, uh, it came back to bite me, in the sense that when they built the building, the residential building had some settlement issues. The owner was upset and wanted to get it fixed, so he sued the contractor. The contractor didn't have the insurance. They checked after the structural engineer and the architect. They didn't have the insurance, so they came after who? The
The geotech.
engineer. and they came after me personally with for my personal assets too. It's almost like they came after me and my firstborn. you know.
Yes.
So you have to be very careful.
Yes.
We need to be smart about the risks that we take. We need to be very careful, and we need to be very honest in our negotiations up front.
Yes.
In situations where we try to come up with qualification based selections, we need to have, then people started playing games with the number of borings, depth of borings, number of tests, trying to cut costs. But you can't overanalyze, but at the same token, you need to have enough analysis and data to be able to back up your recommendations. So we need to be
Yes.
careful
Yes.
as a geotechnical engineer, because you know things flow downhill, and geotechnical
Yeah.
engineers are at the bottom of the hill.
Yeah. Yeah.
And so the things that we need to do, as I said, you need to look at the project, not just for the project alone, you need to look at the surroundings, need to not only look at the current conditions, but also need to look at what the future conditions may be, have that in the framework before you start jumping into doing your investigation, testing, and analysis. And make
Yes.
sure you ask enough questions. Like, as I said, the K value. You need
Yeah.
who's doing it, what are they doing it, how are they doing it, what do you need. Make sure you have all that information before you jump into an investigation and testing program. And then once
Yes.
you've done that, you need to make sure you do the analysis. And the other thing that I always tell people is, before you just finalize a report and throw it across the fence, I always made it a practice to take the findings and discuss it with the structural engineer or the owner or whoever it is, to see how comfortable they are with what the recommendations may be coming. So what
Yes.
we need
Yes.
to do. So discuss it before you finalize it. And even when you finalize it, I always carry the report to the client, sat down with him, and walked him through the report to show him what is in the report, why is it in the report, and what does it mean,
Yeah.
that they have a clear understanding so there's no confusion. So it takes a little bit of hand holding. So I
Yes.
make it a practice. It's all about communication too. So you need to be careful and need to be able to communicate, and make sure you ask all questions, and make sure you communicate your assumptions and your recommendations.
Yes. Yes. Yes.
Using a flat out disclaimer at the end of the report doesn't solve or indemnify you from your responsibilities. So
Yeah.
to be very careful. So it's a lot
Yeah.
of money, and a lot of lives could be at stake too,
Yes. Yes.
especially if you're working on large reservoirs,
Projects.
dams, and even large structures. We have seen even a pedestrian structure like the one that we saw in Florida.
Yeah. Yeah.
It fails, one life is one too many to be lost. So
Yes. Yes.
we'll have to be very careful in how we approach it, but don't be over conservative either.
Yeah. Yeah. Guna, thank you so much for taking out time for the show today and all the service that you have done so far for the civil engineering community and the ASCE. It was a pleasure having you on the show today. I hope you enjoyed as well. Please, could you share any of your final thoughts and advice for our listeners?
Well, as I always tell people, I have no regrets. It's been a great ride. Uh, it's a great profession. It's a building profession, and we are here to enhance the quality of our fellow citizens. It's not just a job.
Yeah.
Enjoy what you're doing, and it's been a fun ride. And I think the future is very bright. The best is yet to come. So my best wishes to everybody. And I always tell people I'm passionate about the profession, and I'm proud to call myself a civil engineer. And I hope all of you feel the same way. And my best wishes to every one of you for a very successful career. And hopefully you will have the same opportunities and ability to work on very interesting projects around the world.
Thank you, Guna. Thank you, Guna. Thank you so much everyone for watching this video. Make sure you like, share and comment your thoughts and questions on this video. Type in any questions that you would want to ask Gunna in the comments below, and make sure to subscribe to the channel for helping us grow our engineering community.